Hi, I'm Balaji Chipada and welcome back to my YouTube channel. In continuation of our Python series for data science, in this video, we are going to cover two most important functions in data frames called loc and iLoc. Many people used to say that these are very confusing and very tough to understand, but don't worry, I'm going to make it very easy for you to understand, and by the end of this video, you will feel like, why do even people get confused in this topic? It is so obvious, right? So without any delay, let's get started. Loc is basically means location. You want to access the data of your data frame based upon the location. Clear? That is what the essence of loc function is. In the previous video, we have seen how you can do indexing and slicing, and we have also seen how you can access the data using head and tail. Now, by using loc function, we are going to access specific rows and specific columns. Now, as usual, let's import pandas and numpy, and I'm going to read in my iris dataset inside my df called df, and this is my dataset. Now, if you see here, this is the index column and we have the id column as well. One thing that I wanted to mention is you can even create a custom index by using a function called setIndex. If you see, normal data frame index starts from 0, but the column id starts from value 1. Now when I execute this, that index id and in place equal to true, what it is going to do is it is going to remove the index column and it is going to make the id column as the index column for your data frame. Here the number of rows and records are 150 cross 6, and if I execute this, now my id will become my index column of my data set and the number of columns become 5. Hopefully that is clear. So by using set index as a function, you can choose to set any of your column as an index to your data set. If you have another list which you want to create as a data set, you can even do that. Let's understand the loc function syntax. It is basically df.loc and it takes two values, rows and columns, separated by a comma. That is clear. Now let's execute this and understand what is the output. So when I say like this, all the rows, comma, all the columns, I'm going to get my whole data set as output. Now if I say df.loc of 1, let's execute this and see. Loc basically takes the actual values of the index and the actual values of your columns. If you see here, the id value 1 we have it, and if I say df of loc of 1, which is the actual value of your id, which is our index column, and I'm able to access all the records of that row: sepal length 5.1, sepal width 3.5, petal length 1.4, and petal width 0.2, and the species is iris setosa. I can access any kind of record by using this direct loc function. And if you see, I can even access this data by using data frame slicing as well. I can just say 0 to 1, and if I execute this, now this will also give me the same output like this, but loc function is much more powerful compared to this function, and we will understand why it is so powerful in the later parts of this video. And I can even access any number, actually df.loc of 53, and this number should be present inside your data set. Hopefully that is clear. And if you see the shape of my dataset df.shape, it is of 150 cross 6, right? Now it would be on 150 cross 5 because we have made id as an index column. Now what if I give 153 here? This is not inside your index, right? Let's execute this and it will show you a key error. What does this mean is it is saying that 153 as an index value is not present inside your data frame. You should only give the values which are present inside your index. If I execute this, it will throw an error because here if you see, the first element should be your rows and separated by a comma, second element should be your columns. As I mentioned before, loc function only takes the actual values. Here I am specifying 2, but in my columns df.columns I don't have the value as 2. I have the records as sepal length, sepal width, petal length, and petal width. So that is why Python is not able to identify what is this 2 means. So if I say something like this, it will execute because I have this column. Now what is happening in this scenario? It is going to get me the fifth record, okay, which where index is 5, and it is going to get me the value of the column called sepal width. Hopefully that is clear. And I can even access multiple records at the same time. Let's say I want to access 3 records which are of index 3 and 5 and 50 and 100. And I can do like this, and I get these values. Now little bit deep into this lock function and understand what will happen if there are multiple index of the same value. Here I'm reading my dataset again and I'm putting my index as a sepal width column. And if I execute this, now my data frame is inside df1. And if you see here, my index value starts from 3.5 and then 3.0, 3.2, 3.1, and again I have 3.0. If you notice, I have duplicate index values inside my data frame. If I do like this df1 dot lock of 3, what it will return is, it will return me all the records in which the index value is 3. And if I execute this, I get this as an output. So these are all the records in which my index value is 3. Hopefully that is clear. And I can even do multiple indexing as well, and it will give me all the records in which index value is 3 and 2.5. If you notice here, I have 2.5 index values as well. And I can even only get only 2.5 index. That is also quite common. Now I can combine this with the column names as well. Let's say I want to understand, or I want to see the petal length column in which the index is 2.5 or sepal width is 2.5. I can just say like this. So df1.log get me the 2.5 index values, and in that get me this petal length value itself. And if I execute this, so these are all the records in which sepal width, which is my index, is 2.5, and correspondingly the petal length is 3.9, 4.9, 4.0 likewise. Now let's go back to our original df, which is our index as 1 2 3 4 up until 150. And now let's execute this. I can get multiple records at index values with multiple columns as well. So this is the power of lock function, guys. By directly accessing the index values and the column names, you are able to extract the data that you want very accurately, right? And I can do a lot of things. Now this is powerful. So I have this data frame df. Okay, now let's say I want to visualize, I want to see all the records in which my petal length is greater than 6. So I can just do like this, df.log df of petal length greater than 6. So what we are saying is, here what it will do is, and first it will check df of petal length, and for every value it will check whether it is greater than 6 or not. If you see, this is the petal length column, and this is not greater than 6, not greater than 6, not greater than 6. Likewise, it will check for every column, and wherever it is true, it will return those records. Okay, hopefully that is clear. And if I execute this, I get all the records in which petal length is greater than 6. And then I can mix and match with other conditions as well. So what I'm saying is, get me all the records in which petal length is greater than 6, and get me the records for those for sepal width only. So if you see here, this is your row, right? And this is your columns, right? So what I'm saying is, df.log get me all the records in which petal length is greater than 6, and for those records only retrieve sepal width. And if I execute this, I get the output as this. Hopefully that is clear. And I can mix and match a lot of other stuff, guys. All the operators that we can do here. Let me zoom out a little bit so that it is very easy for you to understand. So here what I'm saying is, df.log df of petal width greater than 1, and then df of sepal width less than 8. So here this is one condition and this is another condition. Now it will get me all the records in which true or false. For all those checkings, it will also check true or false, and wherever both are true, because of AND function, it is going to return those records. If it is an OR function, whenever both are false, it is not going to return. And if I execute this, I will get the output in which petal length is greater than 1 and sepal length is less than 8. You could do as many possible operations that you can on this data frame using this lock function, guys. So this is the power of lock functions in data frames. And make sure you remember that whenever you are using lock function, it is the absolute values of index and the column names. Now coming to the next one, iLoc. The name itself suggests that it is an indexed base. not an column based or name based, not a original value actually. So let's print the df here, and then now I will make the sepal width as an index so that you will understand it little bit clearly. Now we are going to read the dataset, iris dataset, and we are going to set the index as sepal width. This is important, I will explain why. Now if you see, my sepal width values are from 3.5, 3.0 like this. If it is a traditional data frame, okay, my index value starts from 0, 1, 2, 3 up until 149, right? Now my index values are different. My first value is 3.5 and 2.0 and 3.2. And whenever we are using loc functions, we are saying that give me the actual value of index. Okay. And when I am going to use iLoc, I have to treat this as another index, and it will be marked as 0, it will be marked as 1, and I will say get me, if I do like this, I will say get me the first two records of my data set. Hopefully that is clear. Now what I would do is df1, let me execute df1 here. Okay, and now df1 dot iLoc of 0. If I do this, I get the first record, which is of 5.1, 1.4 and 0.2. 1, 5.1, 1.4, 0.2. If you notice, even though the index value is 3.5, we were able to access this record because of its I functionality, because it is going to treat them as another index 0 to 149. Hopefully that is clear. And even for the columns, this will be treated as 0th column, first column, second column, and third column, and fourth column. You don't need to give, or you cannot provide the actual column values inside iLoc. You have to treat them like an index that you treat like an list as well. Hopefully that is clear. The difference between them, you need to understand it clearly, guys. So if I do df1.iLoc of 5, it is going to return me the sixth element, 0, 1, 2, 3, 4, 5, 6. Okay, it is not present here, but this is the sixth element. And I can get multiple records by using this as well, using iLoc. And I can get, but the first three records, they're all the normal list indexing likewise, guys. Now this is interesting. So what I am saying is I'm writing a function inside my iLoc function. So what I'm representing here, lambda, hopefully you remember the lambda function. What I'm saying, get me all the indexes, and in those indexes get me the indexes in which it is divisible by 2. And if I execute this, I get these two records. These are the two records in which my index divided by 2 equal to 0. Hopefully you understand that. And here now we will access the columns as well. So what I'm saying is get me the first two records, or 1 to 2 records, and then get me the columns in which it is from 0 to 3. And if I execute this, I get these ones. So if I do df.columns, and these are marked as 0, 1, 2, 3, and 4, right? So what I'm saying, get me all the values from 0 to 3, and 3 is not included, right? Because last one is not included. So I will get ID, I will get sepal length, and I will get petal length, centimeter. Hopefully you understood that. And I can do like this as well. I can do as many manipulations as possible, guys. So this is the difference between iLoc and loc. So if you see this, I am accessing my second index element and the second column, sorry, it's third column, right? Index starts from 0. So what I'm doing is, let me do df.head. If you see, so this is index 0, 1, and 2. It is index 0, 1, 2, and 3, and 4. Now by doing this, I'm saying get me the index second record, and inside that get me the second column value. So this is the value, which is 1.3. So I can pinpoint or accurately access the data using this iLoc and loc functions, and I can even modify the elements using iLoc and loc as well. Now if I do df.head, now the element at that position will become 100. If you see, this is 100. So these are the differences between loc and iLoc, guys. Hopefully you understand the differences between loc and iLoc. iLoc uses the index values. We have I inside the iLoc, okay? And loc uses the actual index values and actual column values. And iLoc uses index values for the columns and the rows as well. And you can access any element inside your data set. And if the index is not available, it is going to throw you a key error. And you can even modify the elements using iLoc and loc. And you can do a lot of arithmetic operators as well, and comparison operators as well, using loc and iLoc. So by using these functions, you will be able to understand the data and manipulate the data much more efficiently. Hopefully there is no doubt, and hopefully you understood the concept and you learned something new from this video. And if you are liking what you are watching, please do subscribe and click that bell icon to get notified daily, and we will meet in the next video.